Hello, and thank you for your interest in our contribution to KSEM 2022. I'm Huifan from Beijing University of Posts and Telecommunications. Today, I will present our paper, Open Relation Extraction via Query-Based Span Prediction. To begin, our task deals with open relation extraction that identifies an arbitrary phrase to specify a semantic relationship between arguments within a context. For instance, we have a context. Researchers develop techniques to acquire information automatically from digital texts. And an argument pair, researchers and information. An ORE system would extract the span acquired from the context to denote the semantic connection between researchers and information. Relation extraction is fundamental to various downstream tasks, such as constructing knowledge graphs and computing sentence similarity. The IE task can be divided into two paradigms, open and closed relation extraction. But for OpenRE, conventional closed RE considers only a predefined set of relation types on small and homogeneous corpora, which is far less effective when shifting to general domain text mining that has no limits in relation types or languages. And OpenRE was introduced to alleviate the constraints of closed RE. Now let's review some previous works on ORE. We can categorize them into pattern-based and neural approaches. The pattern-based are largely based on syntactic patterns and heuristic rules that are dependent on external NLP tools and language-specific relation formations, but they cannot handle the complexity and diversity of languages well. Meanwhile, the neural approaches typically adopt the methods of sequence labeling or span selection. The previous SOTA model is Lauren, but based on our comparison of architectures, Lauren suffers from inherent problems in learning long-range sequence dependencies that are basic to computing token relevance to gold relations. To sum up, we have three contributions in this work. First of all, inspired by the broad applications of machine reading comprehension and transformers-based pre-trained language models like BERT and SpanBERT, we propose a novel query-based open relation extractor, QoRE, that can process multilingual texts for facilitating large-scale general domain KG construction. Secondly, we carry out extensive experiments on 7 datasets covering 4 languages, showing that QoRE models outperform conventional rule-based systems and the SOTA method Lauren. Lastly, considering the practical challenges of ORE, we investigate the zero-shot domain transferability and the few-shot learning ability of QoRE. The results illustrate that our models maintain high precisions when transferring or training on fewer data. Now we come to the next part, approach, and we will focus on the QoRE framework. Given an argument pair and its context, we first create a query from the arguments based on a template and encode the combination of query and context using an LM. Finally, the span extraction module finds an open relation by predicting the start and end indexes of a subsequence in the context. You may be curious about how we create a query. In brief, we adopt a rule-based method to create a query template having 2 styles, the question mark and language-specific natural language styles. QM takes the form of a structured argument relationship triple, while in the NL style, each language has a particular template that is close in meaning. Next, I'd like to describe the span extraction module. We utilize two feed-forward networks, followed by the softmax normalization, then take each contextual token representation from the encoded as the input to produce the probability of each token being selected as the start or end of relation span. Let's turn to the next part, experiment. We will first talk about the experimental setup, then concentrate on the result analysis. We propose three hypotheses and design a set of experiments to examine the performances of QoIE models. In Hypothesis 1, by conducting extensive comparisons with the existing OIE systems, we aim to analyze the advantages of QoIE framework. We assume that for extracting open relations in 7 datasets of different languages, our models can outperform rule-based extractors and the Southern neural method Lauren. Before we go on to Hypotheses 2 and 3, we will have a look at the background, which deals with the challenges for OIE systems, including corpus heterogeneity and automation. Thus, we carry out the evaluation on the two challenges from the aspects of zero-shot domain transferability and few-shot learning ability, which we interpret in the following. First, heterogeneous datasets form an obstacle for linguistic tools, since they commonly work well when trained and applied to a specific domain, but are prone to produce incorrect results when used in a different genre of text. As QoIE models are intended for domain-independent usage, we do not require using any external NLP tool. And we access the performances in this challenge while zero-shot domain transferring. The other challenge is automation. The manual labor of creating training data or extraction patterns must be reduced to a minimum. Our model does not need predefined extraction patterns, but trains on amounts of data. We conduct few-shot learning by shrinking the size of training data for the evaluation of this challenge. It is significant to evaluate an extractor on the challenges, so we investigate the zero-shot domain transferability and the few-shot learning ability of QoIE models. In Hypotheses 2 and 3, we assume that our model is able to perform effectively when transferring to another domain or when the training data size reduces. We evaluate on 7 public datasets covering 4 languages: English, Chinese, French, and Russian. And we keep track of the token-level open relation extraction metrics of F1 score, precision, and recall. In the experiments, we compare QoIE models with a variety of previously proposed methods. We denote the English and Chinese extractors and the models capable of processing multilingual text using the superscripts. Next, we will move on to the experimental results. In H1, the comparison results of tables 2 and 3 show that QoIE models outperform all the baselines on each dataset. For pattern-based models and NGDGNN, their dissatisfactory results are primarily due to the dependence on intricate language-specific relation formations and error propagation by the used external NLP tools. If we contrast with the Southern method Lauren, we can see that QoIE achieves substantial improvements over Lauren based on an in-depth analysis of the architectures of both models. The improvements are due to the better sequence representations with long-term dependencies, a basis of computing token relevance to goal relations. In Table 2, if we concentrate on the BERT-encoded and span-BERT-encoded QoIE models, we find that the results from the span-BERT-encoded are relatively more significant than the BERT-encoded, which is in line with the advantage of span BERT over BERT on the span extraction task. To further trace the origin of the significant improvements, we conduct an ablation study from two perspectives: the query-based span extraction framework and the pre-trained language model. The results indicate that both have a considerable impact on promoting the extraction. Let's turn our attention to the second hypothesis. We consider that a model trained on data from the general domain does not necessarily achieve an equal performance when testing on a specific domain, such as biology or literature. So we evaluate the zero-shot domain transferability of QRE by training models on the general domain, LSOIE wiki, and testing them on the science domain, LSOIE science. From Table 5, we notice that the slight decline in QRE performance, showing that our model has superior domain transferability. As for Hypothesis 3, few-shot learning ability, we carry out a set of experiments with shrinking training data to compare our model with BERT tagger. When reducing the training set to 6.25%, our model results in a slight decreased F1 score compared with using the whole training set. The results imply that the query-based span extraction framework may bring more enhanced few-shot learning ability to our model. We also conduct case studies to investigate the correct and false extractions from our model. We notice that QRE is better at handling cases where arguments separately locate in main and subordinate clauses than Lauren. We analyzed the false cases and summarized that most errors occur in situations where the relation between arguments concerns modal verbs or auxiliary verbs. In these cases, QRE extracts either more or fewer words than good relations. Now, I'd like to end this talk with a summary of the main points. Our work targets ORE using a novel query-based extraction framework, QRE. The evaluation results show that our model achieves significant improvements over the SOTA method Lauren. Regarding some practical challenges, QRE models show excellent zero-shot domain transferability and few-shot learning ability. In the future, we will explore further demands of ORE, such as extracting multi-span open relations and detecting non-existent relationships, and present corresponding solutions. Thank you. I'm happy to hear from you and your questions.